All right, we are back with 2.4, completing the square. So many of the quadratic equations that we've done contain expressions that cannot be easily factored. Everything that we have done so far has been factorable, but for equations containing these types of expressions, we can learn to use square roots to find the roots. So whenever things aren't factorable, we can just use square roots in some cases. That leads us to the square root property. So to solve a quadratic equation, you can take the square root of both sides. Make sure that you consider the positive and negative square roots. So if I have x squared equals 15, I can take the square root of both sides. That gives me just x on the left side. And on the right side, that would be plus or minus the square root of 15. Now you might be asking why it would be plus or minus. And the reason for that is, if I have the square root of 15 squared, that cancels the square root out, and that's just 15. But if I have a negative square root of 15, and I square that, two negatives multiplied by each other gives us a positive. So that's also going to be positive 15. So that's why we have to have a positive and a negative each time we take the square root of the variable. So if I take the square root of a variable on the left, it's going to give me a positive and a negative on the right. If I look at this equation, I'm starting with 4x squared plus 11 equals 59. So if I look at this on the left-hand side now, I can't really do much with that. What I can do is subtract the 11 over to the other side. That would give me 4x squared equals 48. Divide by 4 gives me x squared equals 12. Take the square root of both sides. Now it's going to give me x equals plus and minus the square root of 12. I can finish that off just by figuring out what multiplies to give me 12. And I'm looking for perfect squares here. So 4, I know, is 2 squared times 3. Square root of 4 is 2, so that comes out in front. And then I can't take the square root of 3, so that's left inside. That would be our final answer. Plus and minus 2 root 3. If I look at this one, and I start by looking at the whole thing on the left side, I can see that this is a perfect square. X squared, that's x to the second power, or x times x. And 36 is a perfect square. So 36 is 6 squared. 6 times 2 is 12. So I know that this is my perfect square. That's going to give me x plus 6 squared equals 28. Now, by starting off this way, it cuts a step out for me and makes it easier to solve. I can take my square root of both sides. This cancels my square out. I'm left with x plus 6 on the left. On the right, that's now plus or minus the square root of 28. Subtract the 6 over. And I'm actually going to put that in front. So that is negative 6 plus or minus square root of 28. Now what multiplies to give me 28? That would be 4 and 7. So when I break that square root of 28 down, that's 4 times 7. There's a perfect square, or a square root of 4 is 2. So the 2 comes out in front. There is no square root of 7, so it stays inside. My final answer is negative 6 plus or minus 2 root 7. What about this one? if I start this one, a couple ways I can do it. I could subtract my 5 over and look to see if there's a perfect square, or I could add my 20 over. That's going to give me 4x squared equals 25. Then I can divide by 4. That gives me x squared equals 25 over 4. Now I can take the square root of both sides. That's going to give me x equals, now this, whenever you're doing a square root on the top and bottom, check to see if they're perfect squares. Square root of 25 is 5. Square root of 4 is 2. So it's plus and minus 5 over 2. If we look at this one, I see I have the 8x in the middle, so I want to check to see if this is a perfect square. And if this is a perfect square, it is. X squared is a perfect square. 16 is a perfect square. What squares to give you 16? That would be a 4 and a 4. 4 times 2 is 8, so I know that that's true. X plus 4 squared equals 49. Now I take the square root of both sides. That gives me just x plus 4 on the left, and then plus or minus 7 on the right. Then I subtract the 4 over. Now, because these are both just whole numbers, I can combine them. Negative 4 plus 7 gives me 3. Negative 4 minus 7 gives me negative 11. And those are my two answers. Now, if a quadratic expression of the form x squared plus bx cannot be factored, or is not a perfect square, then you can add a term to form a perfect square trinomial. This process is called completing the square. So to complete the square of x squared plus bx, you add b over 2 and square it. So if I started with x squared plus 6x, I would do 6 over 2 squared. 6 divided by 2 is 3. 3 squared is 9. So it's x squared plus 6x plus 9. Now the x squared is a perfect square. The 9 is a perfect square. I end up with x plus 3 squared. Now it's important to remember that sometimes people struggle to see this. Going from this step to this one, where I go from x squared plus 6x plus 9 to x plus 3 squared. Whenever you're completing the square, whatever you get before you square it, this 6 over 2, that would be 3. Whatever you get inside of here before you square it is going to end up being the number that's down here. Algebraically, this is just without the example. Be whatever your b is over 2 squared. Whatever was inside of here, remember, comes down to here. So let's complete the square for the expression. Right, the resulting expression is a binomial squared. So let's take the negative 14. We need to put something back here. It's a negative 14 over 2 squared. Negative 14 over 2 is negative 7. So this now becomes x squared minus 14x and then it's negative 7 squared, which is plus 49. You're always going to end up with a positive here because anything squared becomes a positive. Now it says they want it as a binomial squared, which means we need to have two terms. We currently have 3. And this is where we take whatever we got inside of here. Negative 14 divided by 2 was negative 7. And that's our binomial squared. If I multiplied that out, you would see I'd come right back to x minus 14x plus 49. X times x is x squared. X times negative 7 is negative 7x. Negative 7 times x is negative 7x. And negative 7 times negative 7 is positive 49. Combine your like terms in the middle, x squared minus 14x plus 49. That's just running a check to see if I was right. I was. Of course I was. I'm always right. Let's try this one. Let's complete the square. It means we take this number, divide it by 2, and then square it. 4 divided by 2 is 2. 2 squared is 4. X squared plus 4x plus 4. Rewrite it as a binomial squared. That means that this needs to be x plus whatever I got inside of here, which was 2 squared. The key is to get the procedure down on these. You really have to get the process down. Here it gets even prettier. Take our middle term. Three over 2 squared. So whenever you have this, you square the top and then you square the bottom. So it's x squared plus 3x plus 9 over 4. That gives us x plus 3 over 2 squared. So even if that gives you a fraction, you have to be ready for that because it'll still work. All right, that seems like a good stopping point for today. Let's stop there and we'll pick up tomorrow.